Good noon, everybody. Welcome back to Blockhash Live 2021, the fourth edition of annual Blockchain Summit organized by Kerala Blockchain Academy, a center of excellence for blockchain training and research under Kerala University of Digital Sciences, Innovation and Technology. Hope you had a great time in the first half of Blockhash Live 2021. Moving on, we have with us Mr. Anandan R, Research and Development Engineer at Kerala Blockchain Academy on end-to-end decentralized application development in Ethereum blockchain. Anandan is a senior engineer with more than 4 years of experience in blockchain domain. He is currently leading the Ethereum and Corda blockchain team at Kerala Blockchain Academy. Welcome Anandan to Blockhash Live 2021.
Good afternoon, everyone. So today I'm going to discuss or demonstrate about how a blockchain or an NFT marketplace works. I hope everyone, or almost everyone in the blockchain sector knows about the NFT marketplace, right? Like NFTs, it's kind of like a way in which you can represent an asset in a unique asset in a unique way in a digital world. So today, there are many ways in which we can create an NFT marketplace. You can create an auction-based NFT marketplace. You can create an NFT marketplace where there will be a proxy that will act on behalf of you to sell your token. So I'm going to go with a simplistic approach where I will tell you the basic components of the NFT marketplace, and I'll show you a basic application that we will build during this session. So mainly the building or the coding will be concentrating on the smart contract development part. And after that's done, I will walk you guys through the front end part, or the part where the user interacts, like the code part. Okay, so let me start with sharing my screen. Okay. So this will be the application that we are going to build. So as you can see, my architecture for this application is that I'm using a MetaMask wallet for both managing the accounts in the Ethereum network and for establishing connection to the particular node in an Ethereum network. So currently, MetaMask is connected to my local node, for which I am running Ganache, which is actually a simulator. So for development purpose, always running a simulator like Ganache will be better, because whenever you are developing a decentralized application, you have to search through a lot of documentation in the internet, and at that time, running a full node will be very strenuous to your system, and your system might get stuck, and you'll be stuck for some time. So you can use these kind of simulations given by there are a lot of alternatives too, but this is the most one which has a visual touch and all those things. So that's why I choose Ganache. Ganache gives me an edge when developing. It's actually a simple simulation of an Ethereum node. It works like a black box. You give the input and it will return any output that is given to an Ethereum node. Okay, and MetaMask wallet. So basically, my site is asking permission to connect with the MetaMask wallet's account. So for now, I'll just connect with all of the accounts. So the site is created using a React front-end library with the Node.js application. So why I choose React is that it's pretty much popular these days. It's been there for some time, and most of the industry people use it also. And then next thing is, so basically, let me guide you through the application. So whenever you load the application for the first time, you need to establish connection with the MetaMask. As you can later on check it over here. Like you can see, I have 3 accounts in my wallet, and all these 3 accounts are connected with my site. You can see the status over here. And what my application is that my application is able to create a unique token, an NFT non-fungible token for each colors in the color spectrum. So for example, if I am able to give a particular color, so and mint the token, like mint the token means create the token, then that token will be created, and you can see the owner of that particular token, the ID, and the color. It's a simplistic mechanism. And once you created the token, you are able to put that on sale. So you can put that on sale by clicking the sell token. You need to approve that, and as I have created this one second, 739. Yeah, so sorry about that. Seems like there is an error. So that's the beauty with the MetaMask. So when using MetaMask, the MetaMask will run a simulation of the transaction that you are going to run, and it will give you an error if there is an error there already. So seems like I run the wrong version. So I'll just refresh it and run it again. So give me 1 minute. Okay, so seems like there is a small error with the contract. So we'll rectify that as we start the coding. So I'll show you the demo after we start the coding. So sorry about that. So let's start with that. Yeah, okay. So I have a question in the chat. So I'll just address that. So my environment, like my development environment is, I'm using React for the front end. I'm using MetaMask wallet for connectivity with the Ethereum network, and for also managing my addresses. And then I'm using Ganache for the development purpose. Like when I'm going to do development, I'll use Ganache, which is a simulation of an Ethereum node. It will give you the same input and output as a normal Ethereum node, but it won't be that much of a stress when running on your computer. And yeah, so that's it. Like that's the basic architecture. The front end is built using React, and the like front end library used is React Bootstrap, and the wallet used the connectivity mechanism, like the connectivity part with the Ethereum node. For here, I am using MetaMask wallet, and then I have Ganache for which acts as my temporary node, a simulation of the node. So let's start by coding. Let me just start sharing. Okay, so first thing, I'm going to create a new project. Let's call it color token. Yeah, so first we need to generate the template necessary for doing this. So let's see. Now, I'm going to introduce you to a new tool. I mean, most of you guys have heard about it. So for developing and controlling the life cycle, such as compiling it, checking for errors, deployment of the contract, testing the contract, for doing all those things, I'm going to introduce a new tool, or like a tool followed by most of the industries, known as Truffle. So Truffle is a product developed by Consensus. They are a big, large company in the blockchain environment, and yeah, it's a good tool. Like basically it automates all most of the things that you need to do manually. Like most of the time, in most of the use cases, if you are going to develop a smart contract, we do that using the Remix IDE. But in that case, you have to do most of the things manually, like deployment you have to do manually, and when accessing the contract, you have to manually get most of the data regarding the contract. But when using a Truffle, you can automate most of the process. So let's start with the basic template for the Truffle project. So we can create that using the command Truffle Init. So if you guys don't have Truffle on your system, you can install that using an Node.js, like basically Truffle is actually a node module. So just a quick reminder or quick information, the node version I'm using is 16x. So but I have tried this project on 10, 12 and 16, so there is no problem with using any of those versions. And npm version is this. And if you want to install Truffle, what you can do is that npm install, which is the command for installing packages in Node.js, and you can use the -g flag, which means that it will be installed in a global scope, so that you can just simply call the Truffle as a command line tool and followed by simply say Truffle. So I won't be doing that because I already have installed that. So after you have Truffle available in your computer, you can use the Truffle Init command to create a basic simple structure for a Truffle project. So let's say Truffle Init. So if you look back, you can see there are a lot of new files coming here. So let me just open this folder in VS Code. So Visual Studio Code is one of my favorite editors, which comes with most of the plugins that are really helpful when developing smart contracts using these environments. So you guys may go with Atom or like IntelliJ IDE's editor, like any editor is fine. All of those editors has awesome plugins too, but I just prefer Visual Studio Code. So the first thing you can see is that we have a folder for contracts. So this is where will be our contracts will be, the contracts for our project will be located. Then we have a migration folder. So in terms of Truffle, migration means the process of deploying or storing the contract into the blockchain node or blockchain network. Then we have a folder for storing test files, like using Truffle. Basically, Truffle uses like the normal testing libraries such as Mocha and Chai. Chai is an assertion library and Mocha is a testing library. And Truffle uses these to perform unit tests on smart contracts. It's basically like what happens, like you can test what happens when you call the smart contract from a front-end perspective. So you can test that out. Then finally, you have Truffle Config.js, which is actually a simple configuration file in a JSON format that lets Truffle know to which network it needs to connect and which version of Solidity language we are going to use. So now that we are here, why don't we go ahead and configure that for connecting to the local test network. So which is basically my Ganache over here. So basically Truffle, all of the common configurations are already available in the config file. You just need to uncomment that. So here from the 44th line to 48th line in the Truffle config, I have a section called development. So this will be the default settings used by Truffle whenever you are trying to migrate or deploy contracts into the Ethereum network. So as you can see, it's trying to connect to the Ethereum node that is hosted on the local host, and it's exposed on the 8545 port. And the network ID for the node can be anything. We can give stars so that any network ID node will be connected. And followed by that, the version of Solidity we are going to use will be 8.11. Why not? Let's go with the latest one. Like it's almost latest stable one. So we can change that to that one. And yeah, that's the basic configuration we need right now. And we might need more configuration, but we can come back at a later time. Now, now the next thing that we need to do is that we need to create our smart contract. So as you can see, we already have a migration.sol file in our directory, which is basically a file given by the Truffle developers. And what it does is that it basically keeps track of the migration, like how many, if the migration is complete or not. And most of the times we don't need that file. So for now, I'm going to modify this file according to my needs. Okay, so like whenever we are writing a Solidity program, the Solidity program is different from other programs. Like in case of C, you write it, compile it, you get a binary, you then execute that. But unlike here, you have a Solidity program, you compile that, you get a particular format called binary format, like you get it in a binary data form, you deploy that or store that into the Ethereum virtual machine or the Ethereum node, and then you can call that or execute that particular smart contract. And also, unlike many other programs, smart contract has a little bit different syntax. Like you have to specify the licensing scheme or version for your smart contract code, followed by the version of Solidity you are using. So yeah, I only need those things, so I'll go with that. So 0.8.11, I'm going to use that. Okay, so let's start with creating a contract. So as you know, our aim is to create an NFT marketplace. So we need to use a standard given by Ethereum. Like in Ethereum, we have a lot of standards accepted by the community, a lot of token standards accepted by the community. And most prominent one used for creating an NFT token is ERC-721. So if you search for ERC-721 EIP, so EIP is basically improvement proposal into the Ethereum community. You can see the standard definition for these tokens. So these are the minimum functionalities that needed in this contract, or like any contract that claims to be an ERC-20 token standard, sorry, ERC-721 token standard. And like building these from scratch is always a huge job, but like luckily we have people that builds smart contracts and distributes them open sourcely. Like we have people called Open Zeppelin, which actually host a community maintained and vetted repository of contracts. So Open Zeppelin also has an implementation for ERC-721, and we can use that implementation and then build on top of that. So let me show you how we can do that. So for doing that, first we need to get the Open Zeppelin contract. So there are two ways in which you can get the Open Zeppelin contract. So first thing, you can go to the Open Zeppelin GitHub. So Open Zeppelin. So this is the Open Zeppelin GitHub, and this is the repository for the ERC-721 contract. And here you can see the full implementation. And one way you can do is that you can download this entire code into your computer and then import that code into your own contract and then further build on top of that. I mean, it's a manual and tedious process. I'll put the link in the chat for you guys for your reference. Yeah. Okay. So, but the next thing is that Open Zeppelin is actually available as a node module. So you can simply install that node module into your project, and then you can import that without like doing all this manual thing. You can just simply import that into your contract. So let's see how we can do that. So let's go back to the Visual Studio Code. Yeah, sorry, that was the old one. And open a terminal over here. So you can do that by using yeah, so view terminal, or like under the terminal you can use new terminal. It's also sometimes Control Shift tilde key or Control tilde key. So open a terminal, and we need to add a node repo, Node.js project configuration file, so that we can install this node module. To do that, you can use npm init, which will actually create a configuration file for our node project. So if you simply say npm init, and it will ask you a series of questions. You can mostly go with the default answer, like the name, the version, description, like it's a marketplace for NFT. Then the entry point, so that's not the actual entry point. We won't be using the entry point for this project, so you can just simply give something else. So I'll just give main.js. A test command, we'll be using Truffle, not the node, so we don't need to provide the test command. GitHub repository, if you have an associated GitHub repository, you can provide that. Any keywords, author, and the license. So usually I go with MIT, which is actually a cool licensing scheme. And yes, finally you write that. Now you get an additional file called package.json, which contains the configuration for our node project. Now we can install the node module called OpenZeppelin. So to do that, you can use npm install at OpenZeppelin/contract. Yeah, seems like I made a spelling mistake, but that's okay. We can find out by simply saying OpenZeppelin npm, which will give you the first link is usually the link to the npm repository. And once you go to the npm repository, they will also always give you the command for installing that. So you can copy that from here. I'll give you the reference link in the chat. So just copy that, go back to your command prompt, just clear it, right? Yeah. Yeah, so now if you see, when you install a node module or a node package, it will be downloaded to our computer, and we can see that under the node modules. So you can see the node module installed called OpenZeppelin, and if you expand that, you can see it's actually the same structure as the GitHub repository. You have all the contracts available in the OpenZeppelin, and you can simply browse through them, and you can actually read through them, all those things. See, this is one of the easiest way in which you can actually import OpenZeppelin to your contract. So yeah, now that we have the OpenZeppelin available, let's go ahead and import that out to our contract. So import. So we need two things. We need ERC721 token contract, which will be this one. So we can import it by simply saying at OpenZeppelin contracts token import, like using the keyword import followed by the location. So in case of node module, if you like copy the relative path of this module or this file, you can get that, and you simply delete this node modules, and you can just keep the at OpenZeppelin and just enclose that inside a quotes. So that's the first one. And the next thing is that for our contract, like most of the almost all the NFTs has a unique ID, which is used to uniquely identify a particular NFT, and we usually automatically generate that within the smart contract itself. So the easiest way is that you create a state variable, a uint state variable, and just increment that value. But OpenZeppelin also has an incrementing function for that, so we can also import that to our usage. So let's import that also, which comes under the yeah, 1 second, contracts, utils, and counters. Yeah, so this is the one we need to import, which has a library which will be helpful for us to create an incrementing counter. So yeah, just copy the relative path, import. Yeah, so do not forget the semicolon. I forgot that. Don't need the node modules. At OpenZeppelin contracts utils counters.sol. Okay, so now that's done. Next thing we need to do is that we need to define our contract. So let's call it contract. Let's say NFT. Like, it's okay to use the term NFT. It's not reserved. And we need to inherit this contract so that we can use all the functionalities available in that. So to do that, we can use the keyword called ERC721, and then followed by we open the braces for the contract. So one more thing is that as you can see, I have a little bit of intelligence in the intelligence and color scheming in my IDE. So for that, I used this Solidity extension by Juan Blanco. It's a brilliant extension, and he usually updates that usually updates that very frequently. So it's very good to use. Okay. Now the next thing I want to do is that as I mentioned before, what I'm trying to create is that I'm trying to create peg colors with NFT. So for each unique color, there will be each unique token. So first thing, I'm going to use the hex code for representing a color, like a hash FF00, those kind of formats. So let's see, I need to store, the ID for an ERC721 token is actually of the type uint. It's an integer type, but the color scheme or the color code will be, it's a string actually. You can store it as a string. So I need some kind of mapping between them. And in Solidity, we have something called mapping, which is used to create key value pairs. So we can create a mapping for storing the name of the token, like the color scheme or the color name of the token or the color code of the token. So let's start by doing that. So to create a mapping for use the keyword mapping. Then we specify from which, like you have to specify the data type of the things that you want to store. So you first specify the data type of the key. So mine, it will be, sorry, for this, it will be uint 256 or simply uint. Uses equal to, greater than sign, and the data type for the value, which will be string, followed by the name of the mapping, color name. So let's call it color name. And yeah, then the next thing is that I want each color to be unique. So I want to know if when someone is trying to create a new color, if that color already exists in the system or not. And for doing that, let's create another mapping which maps between the existence of a color or not. Like for each color, we have a Boolean value that says if the color is there or not. By default, it will be false because there is no color in our system currently. And whenever we add a new color, we will mark this into true, so that we when the next time a new color is like a new value is being added, we can check if it is already exist or not. Then we need to have a counter, like from the front end, we need to retrieve all the tokens, right? Like to display all the tokens. And it is always better to have a counter, so you know how many number of tokens are there, and you can use that counter to loop through all the tokens and they get all the values. So I'm going to use the counter. That's why I imported the counters library. And to use the library, you can use the syntax using counters, and then followed for we define a data type. So counters.counter. So it's a capital C. Now That's a user-defined data type, and I can use that to create a variable. So let's create a private variable because we don't really need to give that out right now. So private token IDs. So it will be the total number of, it will be used to represent the total number of tokens. Okay, so now this is kind of like an object. It has methods like to increment the counter and to get the counter and all those things. We'll see that in the next slides. Now the next thing I want to do is that I want to store a contract address. So as I mentioned before, there are many ways in which we can create an NFT marketplace. We can use an auction-based NFT marketplace where one person creates an NFT, like maybe an art or maybe something based on something, and he put that on a sale, and people comes and bid for that art, and finally, when the owner is satisfied with the bid, he can approve that bid and get the money. But here, for faster processing, what I'm going to do is that I'm going to assign I'm going to assign a contract to spend the change the ownership of the token on behalf of me. Like I'm going to approve the a marketplace contract so that whenever someone comes and they click buy, he can.
Hello, Anandan.
Yeah.
Sorry to interrupt. There is a question in the chat. Could you please check?
Yes, sure. So I'm not really sure, but anyway, the contract NFT. So when you want to create non-fungible token standard on top of Ethereum, we create that using Solidity contract. So we simply code up a language. We simply create as programming on top of Ethereum, which follows the standard that is approved by the community. And if it follows the standards like the ERC 721 standard, then we can call that as an NFT-based contract. So what I'm trying to create is that I'm following the standard, which is basically developed by the Open Zeppelin. Like the Open Zeppelin guys developed the implemented the standard based on the community standard, and now I am importing that into my own contract, thus making this an NFT contract. So it's simply a program that has the capability of creating a non-fungible asset. I hope I answered your question. Now that we have a mechanism to keep track of the number of tokens that we are going to create, next we need to store the address of the contract that we are going to approve for handling my tokens. Like whoever creates the token, he is going to approve that particular contract, so that whenever someone comes and try to buy your contract, like buy your NFT, the contract itself will be able to verify the amount is received and then transfer the ownership then and then. So let's for storing the address of a contract, we have a variable type called address, and let's call it contract address. Okay. So the next thing we need to do is that we need to assign value to the contract address whenever we store or deploy this contract into the Ethereum node. And to do that, we can use a functionality called Constructor. The constructor is like a function which gets triggered whenever the contract is deployed into the Ethereum node. And to create a constructor, we can use the keyword constructor. Then followed by the input. So that will be address. Yes, like counter is like a yeah. So I mean, just like for example, like instead of using this, you can simply I'm mentioning about the counter. You can simply create a uint variable called counter, and it has an initial value of 0. And whenever whenever an NFT is created, you can simply increment this value and then use that as a total count of the NFT, so that when we want to recover all the NFTs, we can use this as a maximum limit in a loop and loop through them all them. But OpenZeppelin has a better implementation, and most of their implementation is there because it is actually vetted by the community. It's like vetted a lot of times so that there won't be any errors. So that's why we follow these standards by these communities. So you can, if it is too much for you, like, or if it is not that much of a necessary thing, you can simply use a variable, assign it a value, and then just increment that. Okay. Okay, so after that, yeah, so I deleted that. Yeah, so next I need to store the constructor, sorry, create the constructor for assigning the value to the contract address, which will be the address of the contract that will be managing the sales of the token. And one more thing is that the ERC 721 itself has a constructor. Like for each ERC 721, we have some metadata such as the name of that token and the short form of that token. And whenever we inherit an ERC 721 contract, we have to specify that value also. And we can do this by specifying it in our own constructor. To do this, after you have created your constructor, followed by you specify the name of the contract that you are going to inherit, and then pass in the values of the constructor of that particular inherited contract. So here, first we need to specify the name. Let's call it color token, followed by a symbol for that particular token. So these are like used by the like values out there so that you can represent it. Then inside the constructor body, we assign the contract address with the passed in marketplace address. Now, after doing that, next we are going to create a function for getting the current count or the max count of the tokens. So let's create a function for that. So get token count is actually only reading from the state, and if a function is only reading from the state, you can tag it with the keyword view, so that when you execute this function, like in blockchain, when you are reading something, you don't really need to have spent transaction or cost for that. So you can tag it with view, so there will be no transaction cost for that, only for reading function. And followed by, you need to specify the value it is going to return. So you need to specify the data type of the value. It should be UNT 256. Then inside the function, we are going to return that value. So token ID is kind of like an object, and if you want to get the latest or total count, you have to call the member inside that called current, which will hold the token number of tokens that we have created thus far. And the next thing is that we need to create a function for creating a token. So let's start by doing that function, create token. Okay, so and the input will be the name, like the color code for the token. So string. And whenever we are using any dynamically sized variable like string, we can't really particularly specify the size of the variable. It will be allocated at the time of runtime. So we have to use the keyword memory to specify that it's a dynamic type variable, data types of variable. So let's say color code followed by public. So the public is actually the visibility. That means who can access the function from the contract, and public means that anyone can. Basically, the actors that can access the contract are like the user, another contract, child, and the contract itself. So anyone can access this function. And the first thing we are going to check is if this color already exists or not. So we already had a mapping which keeps track of that. So if color exists of color code, like to get the value of the mapping, you would specify the name of the mapping followed by the key, and then you can get that value. So it will be true or false. Then we can, like, if it does not exist, like if this will trigger, this will revert the transaction. The request will revert the transaction if the color already exists. Otherwise, it will continue the execution. So in case we are continuing the execution, we can actually increment the token ID, like so we will use the member function called increment for doing that. So as you can see, we are actually incrementing the count before creating the token. That means our tokens count will start from 1. Like in most of the contracts or most of the NFTs out there, usually starts from 0, but it's your choice. Now let's create a temporary variable for storing the token ID, which will be token IDs dot current. Then followed by, we are going to create a new entry in the colors mapping using that token ID, and pass in the value that we are going to insert. Then we make the color exist into true, so that next time someone tries to input that, we will be able to neglect that. And finally, we need to create the token using this token ID that we generated. So for that, we have a function implemented in the ERC20 contract. So if we go over here inside the ERC721, and if we search for something called mint, so mint is the function to create a new token. It simply associates a token ID to an address. So you need to pass in your address and the token ID that you want to create. So here I'm going to pass call that function. So I have inherited the ERC721 contract, and as you can see, the mint function is of the internal visibility. That means the child contract and the contract itself will be able to access that function. So I'm the child contract, and I'm going to access that contract, then pass in the value. So like I'm going to mint this token or associate this token to whoever that is going to call this function. So to do that, I need to get the address of the caller, and we can use a global variable called message.sender for doing that. And then we pass in the token ID. Okay. Finally, the next thing what I want to do is that I want to approve the marketplace contract to handle the transaction for this particular NFT that I am going to create. So to do that, we have another function called approve in ERC20. So approve. So in the approve, you need to pass who the address of who you are going to approve and the token ID. So let's call approve, and inside that you need to specify who you are going to approve. So on behalf of me, like if I am going to create this token on behalf of me, this marketplace contract will be transferring the ownership. So the contract address that we just initialized, and then followed by the token ID. Now we are done with the first part. Now we are have actually created a contract which has the capability of creating an NFT based token. Now the first thing we need to do is that we need to rename the file. So it's still migration.sol. Let's rename that. And now to check if there are any errors, like there could be spelling mistake or something like that, or syntactical errors, we can use the Truffle to compile this and find out any errors. To do that, you can use the command Truffle compile. So
I think you did a typo for constructor.
yeah. Okay, thank you for that. So as you can see, we are actually we only try to compile one contract, but as you can see, we are compiling a lot of contract. That is because the ERC 721 contract actually has a lot of dependencies, and it is actually compiling all those dependencies and their sub-dependencies. So once you do the compilation, you get a lot of outputs. Like under this, we are using a compiler called Solc. And when you use Solc compiler to compile a contract, you get a lot of outputs. And those outputs in Truffle are known as artifacts. And those will be available under the build contracts. So this one will be for us, like for the NFT contract. And here the most important ones are the API. Yeah, it's a lot of API. And the bytecode. So whenever you compile your contract, or whenever you want to store your contract into the blockchain, you store that in the format of bytecode. And due to the fact that bytecode is a machine understandable code, and we will be using high level programming language to interact with the contract code that's deployed on the node, we need to know how to call a particular code that is deployed. And for that, we use a map like called AB, Application Binary Interface, which actually clearly specify the name of the function. Like if you have a function or anything, something like that, it specify the name, the inputs, the outputs, and all of those things will be clearly specified over here. And we can use this API to access this particular contract. Along with, whenever you deploy a contract into the Ethereum node, you will get a pointer to that. You will get an identity or a pointer to that particular code, and we call that contract address, just like the Ethereum address that we use to access that. Only difference is that this Ethereum address will be controlled by the code that is stored onto that particular location. So using the combination of this contract address and API, we will be able to interact with the smart contract that is deployed in the Ethereum network. So now that we have the NFT contract, next we need to write a contract for managing the sales, which is the market NFT, and we also need to deploy that contract and store that address into the NFT token. Okay, so let's go ahead and create a new contract. Let's call it, let's say, NFT Marketplace. Yeah. Okay, so just like before, we can copy these things, we can reuse these. So we need the ERC 721, and we need the counters also. We also need one more security mechanism. The thing is that whenever we are going to use this marketplace, we will be calling the function in the NFT contract. That means a contract will be invoking another contract, and there are some situations, vulnerable situations, in which when we have A and B contract, and A contract calls the B contract, the B contract might try to access the A contract, like in malicious intentions or accidentally. This will come into like play and have unpredictable state, which will break the machine. So to stop that, we call this kind of malicious practice retency attack. To stop that, OpenZeppelin has a smart contract, and we can use that to stop these kind of attacks. So I'm simply using this because we have a scenario in which we call another contract from this contract. So to stop any kind of malpractice, we can use this particular contract. So it's called a retency guard, and it is located inside security. return card. So let's import that. To do that, let's copy relative path. Okay. For some reason, I'm not getting the chat notifications.
While sharing screen, I think it won't be alerted.
Yeah, maybe that's right.
Hi, Anathan. I have a question. So yes. Can you explain what is the relation between nft.sol and nft marketplace.sol? I couldn't understand why you created another contract.
Yeah. So in case of NFT contract, we basically in NFT contract, we basically has everything to create an NFT token. But if you want to create a sales, like when you use this contract, you create a new token, and then you can use the NFT NFT functionalities to transfer that to another person. But the thing is that you have to manually do all those things. Like after you have created the token, you have to manually get his address, like his identity, then transfer that into him. So, but what we are trying to do is that we are trying to build a marketplace where once I have created a token, like for example, I want to create a token, I should have the feature to put that token on sale, and some other party should be able to come and buy that token without my intervention. So that's why I'm creating another contract which will handle that logic, and I'll also give that contract, like this particular contract, the ability to manipulate my token. So that's why I'm creating an NFT marketplace. So
yeah, thank you.
Yeah. Okay, so yeah, so next is, okay, so let's create a contract. Let's call it NFT market, and I'm going to import the retency guard over here, so that I can use that inside my, and like we can use some of things that we are using over here, like this counters, because whenever I'm going to put my items or my NFTs on sale, I'm going to list them as items in the marketplace. So I need to know how many items are there in the marketplace so that I can loop over them and retrieve them also. So let's call them item IDs, and for the purpose of like just showing it, I am also creating an address called the owner, which will actually be someone as the admin of this contract. Like I'm maintaining this marketplace, right? So whenever someone is trying to make a sale over this my platform, I'll get a commission, and this variable will hold the address of which party that needs to be paid when this transaction happens. It's just a small piece of commission. Okay, so I'll just hardcode the commission so that it will be easy. So I'll call it listing price, and it will be like 0.025 Ether. Then followed by, I need to store the details regarding the item that I am going to list in the marketplace. And for that, I need to create a new data type. Like I need to have a data type with the members, like the item ID, the NFT contract, like for which NFT that we are going to create that, like sell that, then the token ID itself, and who is going to sell that, like the owner of the token, and if it is sold or not. And to create such a thing, we can use something called struct, which is used to create user-defined data types. That and struct can be used to group together normal data types to create like data type kind of things. So inside that, I need to store the item ID. Then I need to store the like which contract this item belongs to. For us, it will be one, but I'll just go with the general mechanism. So address of the NFT contract. Then the token ID. You can say it's U into 256 or U into uint. It's actually an alias for U into 256. Then token ID followed by address, and the whoever is the seller, like the owner of the token, we'll call it the seller, so that when the transaction finishes, we can send him the money. Then in the status, if it is sold or not. Then I'm going to create this struct is only able to hold one item, value for one item. So I'm going to create a key value pair using this struct so that I can store more than one value. So mapping U256 market item public. So it's kind of like an ID to market item mapping. So let's call it that. So I also need to have a function to get the total number of market items. So let's get item count. So that's going to return a U256 value, just like before, and then return the count. So that will be items ID dot current. So next I need to create two functions. One function is to like put the token on sale. So let's create a function called function create market item. So what this is going to do is that this is going to put the item on sale so that another person can see that and buy that. Then here we are going to receive the address for the NFT contract followed by the token ID. Yeah, so this will be public, and whenever you want to send, like whenever you create a market item, you need to send that commission alongside that function. So to do that, you need to mark that function as payable. Only then you can actually send money along with the contract count. By money I mean Ether. Payable. And this function will be the function that calls another contract. So I'm going to use that retency guard that I called before, which is actually available as a modifier. So these are actually modifiers for the visibility and the mutability. Mutability means how the function will interact with the contract state or Ethereum state. So this is actually a custom modifier that is inside the reentrancy guard. So this will prevent any kind of reentrancy attacks. So that's why I'm going to use that. It's just I'm just following the standards. If you want to know more about the reentrancy attack, then you can just refer to the OpenZeppelin documentation. I'll give you the end by the link by the end of the session. So first, it will check if the message or sender, like whoever is the caller, is the owner of the token or not. Like if you want to put a token on sale, you have to be the owner, right? So I'm checking if he's the owner or not. And to do that, what I'm going to do is that I need to use this contract address to call a function that is located inside the ERC721 to know the owner of that particular token ID. And we can do this by calling the ERC721 interface. Like for every ERC721 contract, it will always follow an interface. So we can use that interface. We can literally use that as an interface to call any function inside the contract by passing in the address. So let's call that ERC721 and we pass in the address dot the function that we can use to get the owner of the token IDs known as owner of, and we pass in the token ID. And we end it with a semicolon. We can also give a message, but we can just check that. Then we are checking if they are actually paying the minimum fee listing price. Let's check that. To check that, like if there are either being passed along with the contract call, we can use another global variable called message.value, which will hold how much ether was being passed. So we can like basically check how much was passed. So that will be equivalent to the listing price. If it is not, it will trigger an error saying that we can also pass in a message in the require. So price not either not enough. Next I need to increment the items ID. So increment. Then I'm going to store that into a temporary variable so that I can use it more efficiently. Items ID, let's call it that, and items ID dot current to get the latest value. And next, I need to store the values into this key value pair. Using that items ID as the key, followed by all the values that are needed, and it will be of the type of that struct. Like if you are going to store it into a struct mapping, the value is actually a struct, so we need to store it as a struct. Yes. Yeah, sorry. So the first thing is item ID. You need to specify the item ID, the contract address, NFT contract address, token ID, then like the who are we going to pay, like who is the seller of that token. So that will be the whoever calls this function. Then it's not solved, so we put it as false, and that's it. Yeah, so now we have everything necessary for doing that, and the final thing we can do is that we can simply create another function which basically says that whoever is going to buy that token, he can call this function and buy that token from that marketplace. So let's say function, let's call it create sale, create market sale, and it will have the address of the NFT contract, like to which contract it is associated, and the sales item ID, which will be UIN256 and item ID. And it will also be public and payable because whoever is going to buy the NFT, he has to pay that particular amount. And for us, it will always be fixed at 1 Ether. So it's kind of like I hard coded that. And this will also need the non-return C modifier so that no one will be able to attack that. So first we need to get the token ID, which we can get from this mapping. So mapping key dot whichever member you want to get. So that will be token ID. Then followed by, we are going to require if it is not like we don't want the owner itself to sell that, like buy the token again. I mean, it's not necessary, but I'm just checking if that is going to happen or not. So we can just copy and paste over here, and this will be just instead of double equal to, we are saying that it should not be the owner. Then the next thing is that the amount for the token is paid, that will be 1 Ether. So we need to check if the value that is coming alongside this contract call has 1 Ether associated with that. So to check that, we use message.value double equal to 1 Ether. And if it is actually not enough either, like it's not mandatory to provide the message, but you can give it. Okay, so finally, the next thing we need to do is that you need to transfer the amount to the seller. So we can do that by getting the seller name. So from the mapping, ID to marketplace, and based on the key item ID, you can call the seller that we defined over here. And we can use a function named dot transfer to transfer an amount to that particular function, and the amount will be deducted from the contract. We've been receiving the amount to the contract, so the amount will be deducted from the contract itself. And you can specify how much you want to send. So that will be the equivalent to the message dot value, because that will be what we want to send. Or you can specify one either two. Next thing we want to do is that we want to transfer the ownership of the token to the new whoever call this function, whoever is buying, like calling this buying function. So we want to transfer the ownership to that person. And to do that, just like before, we are going to use the interface to call that NFT contracts a transfer function. So IES is 721 followed by the contract address, and then use transfer from. Like we are using this function so that whoever is approved can use this function to transfer the ownership. So you need to transfer the ownership from the seller to the caller of this contract function. So seller to message dot sender. And followed by the token. Now you need to set the ID to the marketplace, item ID, and set the sold value to true, because we already sold it. Then we can send, now that the transaction or the ownership transaction is complete, we can send money, that commission money or that listing price money to the owner using the transfer function, and that will be the listing price. So that's the contract that handles this sell and buy of the NFT token. And next we can do is that we can basically compile it. Yeah, so that's on line 16. So that was a typo. Instead of unit, I gave unit. Yeah, so that's bool. Sorry for the typos. Yeah, so that's also a typo. Let me just correct the spelling. Yeah, my mistake. That's known. That's the problem. Yeah, so now we have successfully compiled both contracts, and both contracts have no problems. And let's see how we can deploy these contracts. So the thing is that when you are going to deploy the contract, first we need to deploy the Nft Marketplace contract, then get the address of that Nft Marketplace, and then deploy the Nft contract by providing the Nft Marketplace address. So how can we do that? To deploy a contract, in Truffle's words, we call it migration. We go into the migration folder, we have scripts for doing that. And we need to change this into the migration contract script that we want. So first we need to recur the artifacts or the compiled output regarding to these both these contracts. So I need to get that. So this will be Nft market, and let's call this also Nft Marketplace, and let's duplicate that. And now that we have both the AB and the binary code, all the necessary details regarding that, we can use this to deploy our contract. So first, let's remove this. Yeah. So first, I need to deploy the Nft Marketplace. So deploy.deploy. This is an object provided by the Truffle. Using that, we can deploy any contract. And I'm going to use a promise function so that after this deployment is finished, I need to do some other things, such as to deploy the Nft contract. So this is a promise function, dot function, and send it with a semicolon. And inside that, I want to return sorry about that. I need to, after I deployed that, I need to deploy the other one. So deploy.deploy NFT. And as you know, NFT has a requirement of getting the Nft Marketplace address as a constructor. And to pass in a constructor while deploying, you can simply give it after a comma and followed by the Nft Marketplace address. So you can get that simply by Nft Marketplace.address. Now that's done. We can simply say Truffle migrate. And before you do Truffle migrate, make sure that you have your configurations are right. Development. So currently I have a node running in localhost 8545. So this is actually the expose address, and the network ID is actually 5777, but it doesn't matter. It will take in anything. So if I don't have any errors, and if I have written the migration script correctly, then this should work. So yeah, Truffle migrate. The Truffle migrate will once again compile all of the contract, make sure there are no errors, then it will deploy it to the node. Yeah. So as you can see, this will be our final cost. So this is actually a test network, so our cost will be the actual one, but we almost spent 0.06 Ether. So that is the cost for deploying both contracts. So the next thing is that we need to run our application. So I'm going to switch over to the complete version, and I'll just go through all the codes in which how we access the contract and all those. This is the core part where you actually build the NFT contract and you build the marketplace contract. So while last time we had an error regarding that contract. So while I figure out that error, if you guys have any doubts, you may ask that in the chat.
Hi, Nathan. Will you be explaining about React also?
Yes, I'll just go walk through that. We have
Okay.
a little bit time, so I'll just walk through that and let you guys know how that. So yeah, let me just walk through that first. And yeah, so now that you know that we have deployed our contract, like if you say Truffle deploy, sorry, not Truffle deploy, Truffle migrate. This is my complete code. Yeah, so the next thing you can do is that you can actually write a test function to check that. So I already have written that test function. So this is actually the test function. So I hope you guys can see that. Okay, I have high usage. 1 second. Okay, so what I have done here is that just like I did with the migration, I first imported the artifacts. Then using the contract construct, like this is actually the equivalent to the describe in Mocha, and inside that I'm creating a test condition. And the first test condition is I'm just going through all the test conditions. So the first test condition is that we should be able to create a token and execute the market size. So first I deploy the NFT Marketplace contract, and then I deploy the next one, NFT. Then I get the contract address, so that like we get all the details for doing that. Then I create 2 tokens, like I create a black token and a white token from the first account. Then what happens is that I test if they are equal, like the owner is actually the first account. Like after creating the new token, the owner of that token is actually the first account or the 0th account. And I just console out like who is the owner of that first token. Then after that, I put those 2 tokens into sale. And at the time of sale, you need to specify from which account you are actually saying and how much was the listing price. It was 0.025 Ether, and we convert that into way, which is actually the smallest denomination of Ether, and then we specify that. We do that for the both of these, and after that I go make a buy from the second account. So how I got this account is that whenever you use the contract, the Truffle actually gives you an accounts object which will give you access to all the unlocked accounts in the connector environment. So this accounts variable has all the like access to all these addresses in the Ganache environment. So after that's done, I just console log the new owner name and make sure that it's actually the the second account, and we set that to be true also. And to check that if this works, because writing test condition is always better, because I'll be able to check what's the error here just by running this. So if there is some error with the contract, it will not pass. Okay, so there is something like in this contract there is some error with this. So it might be the error with the create marketplace account. And we can see the error here. So the approver color is not the owner. Okay. So if you guys have any doubts, you guys can put that in chat. Meanwhile, I just figured this out. I have an approve. Yeah, that's because I called an extra approve over here. I don't need to do that. Yeah, sorry about that. So check again. So what the testing does is that it will automatically create a simulation environment and not simulation environment. Deploy your contract into that, check all the conditions, and if it is true, it will say it will pass the test. As you can see over here. As you can see, when the contract was minted, this was the first account and he was the owner. And after the sale, the second account became the owner of the NFT. So yeah, seems like that was my error. So I can also run my application now. So let me just simply run my application. After that, I'll just go through the application. So npm, yeah. So my application is React based. So that is located inside the UI folder. So cd UI and npm start. Yeah, before that, I also need to deploy this once. I forgot if I deployed this or not. So Truffle migrate. So if you have migrated or deployed the contract over a lot of time, you can have a fresh migration by saying the reset flag. And the interesting thing with the Ganache is that each and every time a transaction happens, you can see that over here. So you can see the contract creation happen. And yeah, I mean, it's a big contract, so sometimes it's a little slow. So npm start. So I have developed the code in a minimalistic way. So all the codes are written inside the app.js file. And as you can see, the artifacts are also present over here. And how I did is that I actually added a new line into the Truffle config, using which I can actually specify where the build directory, this build, instead of here, I can specify that inside the UISR. That's how the build directory came here. This is a handy way, because the React can't access anything that is outside its folder. So that's why we provide like that. Okay, so now the application is running. You have a fresh application. Yeah, so let me just reject this right away. So I'm connected to the connected. Yeah. So let me just create a new NFT by providing the code. So yeah, I'm just giving the random code. It's always 6 characters. So it created a new NFT of the color like similar to red. Then I can make to sell the token. As you can see, 05E0, that's the current owner, and he's putting that on sale. So after the sale is confirmed, you can go to the marketplace. You can see the seller, like that will be the owner of the token. You can see the price is E1 either. That's actually hard coded, but anyway. Then if you try to buy from the same account, due to the fact that we have given a check, we won't be able to do that. This is actually the great thing with the MetaMask. It will actually show you the error before you actually do that. So you can reject that. I'm going to switch over to another account. So second account, and now so the second account starts with the 4F and ends with 88. So let's try to buy the token and check if the owner changes. So it has been sold, so it has been removed from the marketplace. Let's go back to the collection, and you can see the new owner has been changed. Now from there, like if you want, he can create new token or he'll sell his existing token. He can do all those things. So let's our time is very limited, but still I'll just go through the application, and I'll also give you guys the code at the end of the session, like the GitHub repository. So as I mentioned before, all the codes are actually written in the app.js. And for the front end, I used a React library known as React Bootstrap for like quickly getting the buttons and all those things. I don't really want to mess with the CSS. And the first thing we need is Web3, which is basically a JavaScript based library used to communicate between the node and the front end. So here actually I got the details regarding that contract JSON, the artifacts into these two variables. Then inside the use effect, so the use effect is used to like if you want to call any function or anything at the loading of the page or loading of a component, in case of React it's always component, then you can use the use effect hook to do that. So inside that I actually retrieve the token details and the market details, and I also call the enable MetaMask. So whenever I am calling this function for the first time, you will be able to establish connection automatically. And one more thing is that I call the enable MetaMask function all the time, like whenever you call the mint token or sell token or buy token, so that or at all time we are actually connected to the MetaMask and there will be no other error, no other error. Then I have next thing I do is that MetaMask actually gives us an object to establish connection to the node, like whichever node the MetaMask is connected to, and using that object, I created a Web3 object with a connection to the node that is MetaMask is connected to. Then I need to create two objects for accessing the smart contract, one for the NFT market smart contract and another one for the NFT contract. Then this is actually the enable MetaMask function. It tries to establish connection with the MetaMask. Then the first one is the mint token handler, which is used to call this function, create token function. So to call a function in the contract, you need to have the contract object followed by the methods, then followed by the name of the function, and you pass in the value. Then you also pass in from which address that you want to call it. Then next I want to get the token details. For that I first get the count, like the max count using the get token count. Then I looped in through all those things and I got all the details regarding that, and I pushed that to an object, and then I used that object. So basically this is a use state used to hold that object details, and using that object details I actually project that into the front end. Like whatever you see over here is actually that code over here. And it's the same for the marketplace when I retrieve the data from the marketplace. So this is get item details, and this is for calling the on sale button. And it's the same, you use the NFT Marketplace object to call the create market item contract, and then you finally have the buy token, which calls the create market sale function. So yeah, it was a little bit rushed thing, but if you guys have any doubts, you may ask. And I have if you guys are interested in pursuing this kind of application, if you explore this a little bit more, you may find one or two errors with the logical errors with the contract. And if you guys find that out, you may give me a ping in this marketplace, in this code. So I have put the code for this application in the chat. It's a public repository, you guys can go ahead and access that. And it also has the method to how which you can run that. You guys already saw that, but you guys can use this step-by-step instruction to run your application.